Today we're going to look at graphing with period changes. So we have our general equation, y equals a sine bx plus d. So we talked about a being the amplitude, and remember that amplitude is always at the distance, so it's positive, so that's why you have the absolute value of a. D is the midline, which moves your graph up or down. And now we're going to talk about b, which is on the inside. So remember when we're doing transformations, things on the outside are vertical movements, things that are attached to x, or in this case on the inside of the sine, are going to be horizontal changes. So b changes the period, which is the number of cycles from 0 to 2 pi. And the equation we use is b times the period equals 2 pi. So this allows us to solve to find the period or to find the b value for an equation. So the b value tells us how many cycles the graph completes between 0 and 2 pi radians. If b is greater than 1, then the function is going to repeat itself more frequently than its parent function, which is either y equals the sine of x or y equals cosine of x. If b is in between 0 and 1, the function is going to repeat itself less frequently than its parent function. And so remember that these values we've talked about before. So if b is greater than 1, this is going to be a horizontal compression by 1 over your b value, the absolute value of that. And if b is in between 0 and 1, this is a horizontal stretch by the absolute value of 1 over b. And we use the absolute value because if it was negative, it would be doing a reflection. So we'll talk about that more in a little bit. So we're going to use the equation b times the period equals 2 pi to solve for the period. So if I solve for the period, divide both sides by b, I get the period is equal to 2 pi over your b value from your equation. So we're going to be using this a lot to help us solve. So it's an important formula. Changing the b value of the graph changes the key points on the graph. So keep that in mind. So remember we said we had 5 key points, the maximums and minimums of where the graph crosses the midline. And so to recall, to find the key points on the graph, we divide the period by 4. So that's going to be how we find our new key points. So let's go ahead and look at the sine function. So given the parent graph of y equals the sine of x, we're going to graph the equations below. So the first one we have is y equals the sine of 2x. If it helps you to write your general equation, y equals a times the sine of bx plus d, I would go ahead and do that. So our a value here is what's in front of the sine. If there's nothing there, we know it's just 1. Our b value we can see is 2, and the d value, if it's not there, we know is 0. So the period, remember, we find by using our equation that we know b times the period equals 2 pi. So in this case, that tells us that the period equals 2 pi over b. We just wrote that down a minute ago. So in this case, 2 pi divided by 2 gives us pi. So that changes our key points. So remember, the key points are going to be the period divided into 4 equal parts. So now our key points are going by pi over 4, whereas remember from the parent graph, our key points were going by pi over 2. So down here we have our parent graph graphed. So for your parent graph, you can see this is our first key point, 1, 2, 3, 4, 5. So remember our key points for the parent graph were at pi over 2, pi, 3 pi over 2, and 2 pi. So let's go ahead and look at our new equation, which is y equals the sine of 2x. So for this, I'm going to be using my key points of pi over 4, which are already written on there for you. So 1 pi over 4, this is 2 pi over 4, which reduces into pi over 2, 3 pi over 4, so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So you can see that they're already on the x-axis for you for this equation. So when we are graphing this, we're using our key points. So sine starts on the midline on the y-axis. So we know our midline is right here at y equals 0. So we didn't change that. The only thing we're changing is that b value. So this is our midline. So we start on the y-axis on our midline, and then remember the sine graph always goes up. So now our new key point, instead of being pi over 2, is at pi over 4 for the first one. So we have pi over 4, 1. Then the next key point would be back to the midline, below the midline, and back here. Because remember, we're always following that points on our unit circle. So sine starts at 0, 1, 0, negative 1, 0. So we just changed the key points to being pi over 4. So 0, pi over 4, 0 at, sorry, not pi over 4, but I should say 1. At pi over 2, 0, negative 1, 0. So for this, you can see that from 0 to 2 pi, there are b cycles, so 2 cycles, because if I were to keep going, that was 1 cycle. And notice I just repeated those values, 1, 0, negative 1, 0. And so we have the first cycle here from 0 to pi, and the second cycle is here. So from 0 to pi, there are 2 cycles. That's why we say the b value tells you the number of cycles from 0 to 2 pi. So that's why b is 2. So notice that what happened from our parent graph. So the parent graph is that dotted line. Notice that it has horizontally compressed. So that's why it's opposite thinking when you have these values here. So again, since our b value is greater than 1, that is a horizontal compression by, in this case, it's 1, the absolute value of 1 over your b. So the absolute value of 1 over b is just 1/2. So again, to get that, that's the absolute value of 1 over your b. So b again is 2. So notice when you're doing your horizontal moves, it's opposite of what you think. You think the 2 would be a stretch, but in this case, it's not. It's a compression. So let's go ahead and look at when your b value at this number 2 graph, when your b value is instead of 2, 1/2. So for this graph over here, we have an a value of 1 still. Your d value is still 0 because there's nothing added. Your b value is what's on the inside of the sign, which is in this case now 1/2. So to find the period, we know that b times the period equals 2 pi. So that means that the period equals 2 pi over b, which in this case is 2 pi divided by 1/2. Remember, if you have a fraction divided by a fraction, you keep the numerator, change the multiplication, and then flip the fraction denominator. So that would be 2 over 1. So 2 pi times 2 gives us 4 pi. So the new period is 4 pi. And then the key points again are going to be the period divided into 4 equal parts. So 4 pi divided by 4 gives us pi. So that means our new key points are going to be going by pi. So here we have our parent graph, and I kept those key values as well. So we have 1, 2, 3, 4, 5. So notice that's our parent graph because it stops at 2 pi. So our new graph, we're counting by pi. So this has more key points than we need. So I'm just going to put them up here. So this is 1 pi, 2 pi, 3 pi, and 4 pi. Those are our values that we're using for our key points. So for my graph, I know that it starts on the midline, which we know is at, again, y equals 0 on the y-axis. So we know that's our first point. And then our next key point, it goes up to 1. So at pi is our next key point. We're at 1. Then at 2 pi, we're back to midline. At 3 pi, we would be at negative 1 and back to the midline. So now you can see our graph. If we compare it to our parent graph, it's twice as long. So our parent first wave was this again right here. And so you can see from 0 to 2 pi, the graph that we have is a half of the parent graph cycle. So we would say from 0 to 2 pi, you see a half of a cycle, because you can see this is 1, 2, 3 key points, and to get all 5, you would have to go all the way to 4 pi because we changed period. So that's half of the wave from 0 to 2 pi. So that means this is a horizontal stretch by, again, the absolute value of 1 over b. So the absolute value of 1 over 1/2, which is equal to 2. So again, to get that, that's the absolute value of 1 over b. So, and then 1 divided by 1/2, keep, change, flip. So keep, change, and then flip, which is why we get 2. So again, notice that it's opposite of what you would think it would be. So instead of this being a horizontal compression by half, we are horizontally stretching it by half. And our new key points, if you count again, 1, 2, 3, 4, 5, are the new period, which is 4 pi. So here is, again, our sine equation. So I just want to show you that if I change this b value to be a number greater than 1, notice that means that from our parent graph, which is from 0 to 2 pi, we see more waves. And when it is a number that is in between 0 and 1, you're going to have it with less waves. So that's why we said here, if b is greater than 1, the function repeats itself more frequently. If it's in between 0 and 1, it's going to repeat itself less frequently than the parent function. So let's go ahead and look at the cosine equation. So cosine equation, again, is similar to sine. It's just that it starts at a different value on our unit circle. So we know that sine starts at 0, but cosine starts at 1, and then 0, -1, 0, because we're looking at the x coordinates, remember, from our points, not the y coordinates like sine. So for this, we have our parent graph, cosine already graphed below. We have our, again, general equation, which is y equals a cosine bx plus d. So my a value, if there's nothing in front of the cosine, we know it's just 1. My b value is, in this case, 3, and my d value is 0 because there's nothing being added or subtracted on the outside. So again, the period is b times the period equals 2 pi. So the period is equal to 2 pi divided by b, which in this case is 2 pi over 3. And the key points, again, are the period divided into 4 equal parts. So in this case, the period is 2 pi over 3 divided by 4. So remember, keep, change, flip. So keep the numerator, change, and then this is really 4 over 1. So we flip that to 1/4. So when we go ahead and multiply straight across, we get 2 pi over 4 times 3, which is 12. And of course, that reduces into pi over 6. So pi over, 4, pi over 6. So these are our new key point values, what we're going to be going by. So we have the parent graph there, but on my graph, we're going to do the new key points. We need to add those in. So this is 1 pi over 6. And then you get 2 pi over 6, which is pi over 3. 3 pi over 6 is pi over 2. We're going to keep going. So then 4 pi over 6 is 2 pi over 3. Then we have 5 pi over 6. The next one will be 6 pi over 6, which is pi. Then we get 7 pi over 6. And then 8 pi over 6 is 4 pi over 3. And then we get 9 pi over 6, which is 3 pi over 2 when you reduce. And then 10 pi over 6 is 5 pi over 3. 11 pi over 6 doesn't reduce. And of course, 12 pi over 6 is 2 pi. So all I did was count by my new key point values, which again are going by pi over 6. So for this, if we want to draw the first wave, since this is cosine, we know cosine starts above or below the midline, and since it's a positive a value, that means we are starting above our midline. So we're starting at 1. And then, so if you look back at your circle, so you start at 1, then you go to 0, -1, 0, and back to 1. So 1, our new key point is pi over 6, so 0, -1, 0, 1. So notice that the first wavelength is from here to here, which is the period. And notice that it has horizontally compressed. So this is a horizontal compression by 1 over the absolute value of 1 over b, which again in this case would be the absolute value of 1 over, and our b value is 3, so 1/3. And you can see if I keep going for another cycle, so again we're just repeating this point, so back to the midline, below the midline, at the midline, above the midline. So that gives me a second wave. And if I keep going for another one, 1, 2, 3, 4, 5, that would give me 3 waves. So you can see from 0 to 2 pi, there are 3 cycles. So that's why it's a horizontal compression by 1/3, because from the parent graph we have compressed it in, and that's why the b value is 3, because again there's 3 cycles within one parent wavelength. But again, it's opposite what you think. It's not a horizontal stretch, it's a horizontal compression to get those 3 waves inside the parent graph. So now let's go ahead and look at the next one. So for the next graph, we have our a value for amplitude is still 1, b is now 1/3, our d value is still at 0 for the midline. The period again, so b times the period equals 2 pi. So that means that the period equals 2 pi over b. I like to constantly write that down because it helps me memorize formulas the more I write it down. So 2 pi divided by 1/3. So keep the numerator, change multiplication, and flip. So then remember this is over 1, so that gives me 2 pi times 3, which is 6 pi. So now we have our new period, which is 6 pi. And the key points, remember, are the period divided into 4 equal parts. So in this case, 6 pi divided by 4, which reduces into 3 pi over 2. So now in our graph, to get our new key points, we have to count by 3 pi over 2. So I have down here, this is from the parent graph, which doesn't have all the parent graph points. So the parent graph, remember, key points are pi over 2, so 1 pi over 2, 2 pi over 2 is pi. This is 3 pi over 2, 2 pi. So then this would be 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, and 11 pi over 2. I'm just counting from the parent graph key points. So I'm going to go ahead and now look at our key points, which are now going by 3 pi over 2. So this would be the first one, 3 pi over 2. So to get the next key point, I'm adding another 3 pi over 2. So 3 pi over 2 plus 3 pi over 2. Well, how do you add fractions? You add the numerator and keep the common denominator. So the numerator, when I add it, 3 plus 3 gives me 6, and then pi. So 6 pi over 2 is 3 pi. So the next key point is going to be at 3 pi. And then if I take 3 pi, and I'm going to actually use 6 pi over 2, so I still have a common denominator. So 6 pi over 2 plus another 3 pi over 2 gives me 9 pi over 2. And so that tells me my next key point is right here at 9 pi over 2. Or you can even see on your graph if you count 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the next key point should be at 6 pi. So if I take 9 pi over 2 plus 3 pi over 2, notice I get 12 pi over 2, which is 6 pi. So again, remember, for your key points, you're always just adding those to get the values on your graph. So we start on the midline above, or on the y-axis above the midline is what I meant to say. And for my graph, we have, it starts, of course, at 1. The next key point goes down to 0, but it's not at pi over 2 anymore. Now we're at 3 pi over 2. The next key point would go below the midline, and that's at 3 pi. And then at 9 pi over 2, we would be back at the midline. And then at 6 pi above, because remember, we're following around our circle. So we have 1, 0, -1, 0, 1, because again, it's x coordinates from your unit circle. So 1, 0, -1, 0, 1, and then you just connect those values. And so that would be my graph. So notice from 0 to 2 pi, we have, that's from here to here. That would be a third of a cycle because it's the absolute value of 1 over b. So from 0 to 2 pi, we have it's your b value, so 1/3 of a cycle. I'm thinking of the horizontal compression is going to be 1 over b. So this is a horizontal, not compression, sorry, horizontal stretch from your parent graph, because notice it's bigger than the parent wave. The parent wave goes from here to here, and the new wave is from here all the way to here. So the horizontal stretch by the absolute value of 1 over b, so that's 1 over 1/3, which gives me 3. So it's a horizontal stretch by 3. So if you notice your parent graph, this is one parent wave, this would be the second wave, and the third wave. So notice that it is 3 times as big as your parent graph, so that's why it's a horizontal stretch. But the b value is 1/3 because it's a third of the cycle from the parent graph. Okay, so the next part we're going to look at, it says determine the period, amplitude, midline, and key points. So what I would do is pause the video, do this on your own. When you're done, on pause to check your work. So for the first one, our a value is 2, our d value is 1, and b is 5. So the period, remember, b times the period equals 2 pi. So the period is 2 pi over b. So in this case, 2 pi over 5. And the key points are the period divided into 4 equal parts. So, or you can multiply it by 1/4, it's the same thing. So the key points are equal to 2 pi over 5 times 1/4. It's the same thing as dividing by 4. And when you reduce this, so you get 2 pi over 20, which of course is pi over 10. And for the next one, our a value is 1/4. Our d value is 0. Your b value is 1 over 7, because I can rewrite this as 1/7 x, so it's 1 over 7. So then the period would be equal to 2 pi divided by 1/7, because that's your b value. So 2 pi times 7 would be 14 pi. And the key points are going to be the period divided by 4, which is 7 pi over 2. So the first one, this is because your b value is greater than 1. So remember, that tells us that this is going to be a horizontal compression by 1/5. And this one, because your b value is in between 0 and 1. And so that tells us this is a horizontal stretch by, and 1 over b would be 1 over 1/7, so by 7. And again, that goes back up to what we talked about earlier. And I should have said over here that this is the absolute value. I'll have to add that in on your paper so it's already there. So it's always the absolute value. which makes sense because if it's in between 0 and 1, you have to have a positive value and above 1. But usually I just put the absolute value to help us remind us that the negative is going to be a reflection. So for number 7, for this one, we have our a value. Remember, it's the absolute value of a, so this would be 3. D value is -2, so that's going to move your midline down 2. Your b value is 3/2, so that means that the period equals 2 pi over b, so 2 pi divided by 3/2. Keep the numerator, change to multiplication, and then flip. And then 2 times 2 gives us 4 pi in the numerator over 3, so 4 pi over 3. And then the key points in this case would be the period divided into 4 equal parts. So 4 pi over 3 times 1/4 gives us pi over 3. And so your b value is 3/2, which is bigger than 1. So b is greater than 1, which tells us this is a horizontal compression by 2/3, because you remember you do the absolute value of 1 over b for the horizontal stretch or compression. We didn't have to actually write that. So remember that the a value tells you the amplitude, so that's a vertical stretch. So for number 6, it would be a vertical compression, and number 7 would be a vertical stretch by 3 for the amplitude. That negative means it reflects across the x-axis, and then remember your d is your midline. So for the first one, it moved up 1 at 0 and down 2, and then we just now learned our b value being horizontal stretch or compression. So let's go ahead and look at the multiple transformations. So these are our general equations again, and tells you what each of the values do. Just have it written there again, just so that you have it on this page to go ahead and graph. So let's go ahead and take a look at these graphs. So for this first one, we have our a value for amplitude is 3. Our d value, because there's nothing there, plus 0 is 0. Our b value is 5, and we just did this problem. If you go back up here, we have a 5 for a b value. Our period is 2 pi over 5, and the key points are pi over 10. So the period we know is 2 pi over b, and we know the key points are going to be pi over 10, because again, 2 pi over 5 times 1/4, which is 2 pi over 20, which gives us pi over 10. So that means in order to graph this, I'm going to do my midline first, because we know it's at 0. And for my graph, remember we're going to be counting by our key points, which are pi over 10. So this is 1 pi over 10, 2 pi over 10. I'm just going to do this first and then reduce. 3 pi over 10, 4 pi over 10, 5 pi over 10. And then we're going to reduce. So pi over 10 doesn't reduce. The next one does to pi over 5. And then 3 pi over 10 doesn't reduce. 4 pi over 10 becomes 2 pi over 5. And then we have 5 pi over 10, which is reduces into pi over 2. And then 6 pi over 10 becomes 3 pi over 5. And then 7 pi over 10. And then 8 pi over 10, 4 pi over 5. 9 pi over 10. 10 pi over 10 is, of course, pi. 11 pi over 10. And then 12 pi over 10 is 6 pi over 5. So all I did was reduce those values. This is negative pi over 10 and negative pi over 5. So it's always important to label your x-axis and, of course, your y-axis. So we need to know that scale as well. So this is a cosine graph. So remember, cosine starts above the midline in this case, and it's going to be 3 above the midline. So 1, 2, 3, back to the midline. 3 below the midline, 1, 2, 3, back to the midline, and 3, 1, 2, 3 above the midline. So that would be our first wave, which makes sense because the period is 2 pi over 5. So if we graph another wave, we're just going to repeat those values. And then we could graph another wave if we wanted to. We only had to do 2 cycles as a minimum, but it never hurts to graph more than you need. So that actually gives us 3 waves on our graph. And then we could also, again, go backwards. So if I went backwards, your graph would go this way. That's half of a cycle, of course, because I don't have the graph that stops there. So that's not actually a full cycle going the other opposite direction, but that's okay. So let's go ahead and look at the next one. So for this one, we have our a value, which is -1. So the opposite value of -1 is just 1. So the amplitude is 1. The d value is -1. So that means we're going to move our midline to y equals -1. And our b value is 2/3. So we know that the period equals 2 pi over b. So 2 pi divided by 2/3. Keep the numerator, change and flip. So that gives us 3 pi. And so then the key points are the period divided into 4 equal parts. So 3 pi over 4 is what we're going to count by. So we have 3 pi over 4. And I'm basically adding the numerator and keeping all the denominators over 4. So 3 pi plus another 3 pi would give me 6 pi over 4, 9 pi over 4, 12 pi over 4, 15 pi over 4, 18 pi over 4, 21 pi over 4, 24 pi over 4, 7 pi over 4, 30 pi over 4, 33 pi over 4, and 36 pi over 4. And of course, we want to reduce those values. So we get 3 pi over 4, 3 pi over 2, 9 pi over 4 doesn't reduce. And then 12 pi over 4 is 3 pi, which makes sense because that's going to be our first wavelength. And then 15 pi over 4, 18 pi over 4 is 19 pi over 2, 21 pi over 4, 6 pi, and 27 pi over 4, 15 pi over 2, 33 pi over 4, and 9 pi. So for the next one, we already did the midline. We have our new key point values, and it's a sine. So sine starts on the midline. So that means we're starting here. Our amplitude is 1, and we have a negative a value. So that, again, is reflection. So that means we're going to go down first. So now we would go down below the midline, back to the midline, above 1 the midline, and back to the midline. So remember, the amplitude, you can always count from the midline up or down that value. So that would be our first wave. And then we can keep repeating those values for a second wave. And then we could repeat them again for a third wave. And we could, of course, go backwards. So that would be half of a wave. So that gives me my new graph. So again, it's very important to make sure to label your x and y axes with your key points because these graphs do change a lot, and that's it for the graphing sine and cosine with the period changes.